places where we are going to use it. This is just the first day of it. So today we'll look at a couple different calculations we can do. We will have more later in the week. So my suggestion is to get in the habit of writing out what formula you're using and labeling your variables. Today that's probably not going to seem like a big deal because we don't have very many options that we're using. They're distracting. I want my windows open. But once we throw in several more variables and formulas, it will be a good strategy to have. So we're going to try to use good notation today as we go through this. The first thing I want to remind you of, we were looking at our radian measure, and we said that theta in radians is S divided by R. We said 1 radian is the size of the angle so that the arc length and the radius are the same. And so if you want to find out how many radians an angle is, you take your arc length divided by the radius. Well, if you manipulate this formula and multiply by R on both sides, we get a new formula. Not really new, but written differently. S equals R theta. S is arc length. Okay, so this is talking about theta is a central angle in a circle. That just means it's centered at the center of the circle, going out. R is the radius. Then the length of the arc, so that's the distance on the outside of the circle, is S equals R theta. But the key to all of this is that theta has to be in radians, because we had this measure for theta when we were calculating our radians. So this only works if that angle is given to you in radians. Now remember, does it have to have a pi in it to be radians? No, it's just anything without a degree symbol is a radian measure. All right, so let's take a look at a couple examples. A circle has a radius of 25.60 centimeters. How many significant digits is that? Technically, if there's a decimal, you would also count 0. So it's technically 4 significant digits. Find the length of the arc. So the length of the arc, that's the distance on the outside of the circle. That's S. That's what I'm trying to find. Intercepted by a central angle having each of the following measures. So on part A, my theta is 7 pi over 8. So if I want my arc length, S equals R theta. So my radius is 25.6. Theta is 7 pi over 8. And we have different options for how we might answer this. If I told you to leave it in terms of pi, you could do 25.6 times 7 over 8. And we get 22.4 pi. Or if you multiplied out the pi, make sure you're using the pi button on your calculator, not just 3.14. So that comes out, if we wanted to do significant digits, 70.37. S is a distance, so what would my units be? And remember when we were doing our radian calculation, we said that the arc length and radius are the same units. So I would accept either of those. I don't care if you leave pi in it or multiply the pi out. You should get comfortable seeing it either way. They are equivalent answers. All right, part B. I told you that theta is 54 degrees. Do we have a problem? Why? It has to be in radians. So how would I change this into radians? Right, we said 180 degrees is equal to pi radians. So if we want degrees canceled, they go on the bottom. So I don't want to multiply off the pi, I want to keep this as exact as I can, so I can use it later in my problem. So 54 over 180 gives me 3 pi over 10. So now we can do S equals R theta. Radius 25.6. Theta 3 pi over 10. So if you take 25.6 times 3 over 10, that gives us 7.68 pi centimeters. Or if you chose to multiply out the pi, that would be 24.13 centimeters. Those are equivalent. Any issues with those? Let's take a look at this one. Erie, Pennsylvania is approximately due north of Columbia, South Carolina. The latitude of Erie is 42 degrees north, while that of Columbia is 34 degrees north. Find the north-south distance between the two cities. All right. So what they're giving us. Okay, do we all agree with what shape is the Earth? Round. Okay. We don't have any naysayers anymore. So it's telling us that one of these cities is at 34 degrees north, and one of them is at 42 degrees north. We're trying to find the distance between these cities. So if we were drawing them, okay, this one's 34 degrees. This one is 42 degrees. But if I'm talking about the actual distance between them, what I'm looking for is my arc. I'm trying to find my S. I gave you the radius of the Earth is 6,400. My angle. What angle am I actually going to use? So it's saying from here, it's 34, that's 42. If I want this angle, so if I'm looking for this distance, I need the angle right here. What's that angle measure going to be? How'd you get it?
42 minus 34.
Yeah, we just need that distance between them, so that's 8 degrees. Okay, is there a problem with that? No, except if I'm going to use my formula, what do we have to do first? Yes. So the conversion into radians shouldn't be a big deal. It's multiplied by pi over 180. Okay, if we reduce that, we get 2 pi over 45. So now we want S arc length, so S is equal to R times theta. And R is 6,400. Theta, 2 pi over 45. And this one, let's go ahead and just multiply out the pi, because if you're going to give me a distance on the Earth, you're telling me how far apart two cities are, we're probably going to multiply that out. So I got 893.61. And of course, I didn't specify, but if I wanted you to give me significant digits, what would you have said? Mm-hmm. So there were only 2 significant digits given in the problem, so if I asked for that on your answer, you would tell me the 890. Is it okay? Let's try another one. A rope is being wound around a drum with a radius of 0.327 meters. How many significant digits is that? 3. How much rope would be wound around the drum if the drum is rotated through an angle of 132.6 degrees? So that's my angle. If I'm looking for the amount of rope that's being used, the rope is going around the outside. The distance around the outside of a circle, that is our arc length. So that's what we're trying to find. What do we have to do first? So I get a beautiful 221 pi over 300. So then we can do S equals R theta. So the R is 0.327. Theta 221 pi over 300. I get 2.4, sorry, 0.241 pi, or if you chose to multiply out your pi, 0.757. And what would my units be? So either of those answers is okay with me. Any questions there? Let's try this one. 2 gears are adjusted so that the smaller gear drives the larger one. What does that mean? I'm making the small one spin, and because they're touching, as that one spins, the bigger one spins. Okay, the radii of the gears are 3.6 inches and a 5.4 inches. So let's organize this. We have 2 different gears here. We have the small one and the large one. My small one, my radius is 3.6. The large one, it's 5.4. The smaller gear rotates through 150 degrees. Through how many degrees will the larger gear rotate? So I'm looking for the degrees. I'm looking for the angle for the big one. Okay, so first thing, I have information about both gears. What is something that they have in common? What would be the same for both of these gears? They have a different radius, they have a different angle. But when the small one spins, that causes the large one to spin. So don't, as they spin, they're touching, right? So that distance on the outside of the circle is the same for both of them. So they have the same S. Can we find the S for the small here? Yeah. Okay, 150 degrees, what is that in radians? So if we do S equals R theta, 3.6 times 5 pi over 6, we get 3 pi. But that is the same as the S over here. So now what I know is that in the large gear, my S is 3 pi. So we can do S equals R theta again, but this time I'm solving for theta. So my S is 3 pi, my R is 5.4 theta. Okay, if we divide by 5.4, that gives us 5 pi over 9. Right, am I done? I asked you to do how many degrees. To put theta into a formula, you have to have radians. That means when you find theta using the formula, this is radians. So if I want degrees, what do we have to do? Pi's cancel. So 5/9 times 180 is 100 degrees. So we have to think about what they had in common and use that to solve for our missing piece. Any questions there? So you don't always have to be solving for S on these. I could ask you to solve for any of the variables. You just use your formula and solve for whatever you need. Second thing I want to talk about today is area of a sector. So a sector is a portion of a circle. In the past, you have found area of an entire circle. We want to know, what if we aren't talking about a whole circle? We just want a slice of the pie here. How do I find that area? And we can get it kind of by doing a proportion. We know that in a whole circle, what's the area of a circle? How do you find it? Do the formula for area of a circle? R squared. So I'm going to set up a proportion. I want a portion of a circle. Okay, so I'm going to say if I take my area and divide it by theta. Theta is my angle. If I'm talking about the whole circle, how many radians is an entire circle? 2 pi. Okay. So, in a circle, area is pi r squared divided by 2 pi. Okay, so if I were doing the area divided by the angle, that's pi r squared divided by 2 pi. So if I'm trying to solve this proportion for my area, so if I want a portion of a circle, then I can look over here, my pi's will cancel. So I get r squared over 2 theta. Or another way of writing that is 1/2 r squared theta. So that is actually the formula for area of just a sector. And that's what I have on the next slide. So just so you have that for you. One thing to remember, if you are looking at this, what does theta have to be measured in? Radians. Theta is always in radians. Okay, so let's try a couple examples of that. If I want the area of a sector of a circle having a radius of 15.2 feet and a central angle of 108.0 degrees. So how many significant digits does this one have? 4. So I gave you the radius. I gave you the angle, but it's in degrees, so we have to convert it into radians. So that gives us 3 pi over 5. So our formula, area is 1/2 r squared theta. So the area of the sector is 1/2. My radius was 15.2 squared. My theta, 3 pi over 5. So again, you have the choice if you want to multiply out your pi or not. 69.312 pi, or if you multiply out the pi to 17.8 if we wanted to match significant digits. What are the units if you're talking about area? Square feet. I want you guys to try one. So here is your problem. So 90 degrees is what angle in radians? And the radius is 30. So area is 1/2 r squared theta. 1/2 times 30 squared times pi over 2. If I said 3 significant digits, that means let's go ahead and multiply out the pi. So 1/2 30 squared times pi over 2 would give us 707. And area is always squared, so square feet. Any issues with this stuff?